So let's take a quick moment to talk about covalent bonds. Covalent bonds have a couple of traits we need to be aware of. First of all, they use the prefixes when we name them. Secondly, these always occur when atoms will share pairs of valence electrons. When this happens, the atoms are able to have a complete octet, or in the case of hydrogen, a complete duet, meaning that their valence level is completely filled and they are satisfied. There are no ions that are formed and there are no electrons exchanged when we have a covalent bond taking place. Something else to be aware of is that these occur between non-metals only. There are never any metals that are involved in any type of a covalent bond. Here's an image of what we're talking about. We know that oxygen has 6 valence electrons. We know that carbon has 4. We know that when oxygen is gaining electrons, it wants to gain 2 more. And we know that carbon wants to gain 4 more in order for all 3 to have a total of 8 valence electrons. As you can see from the image, the red dots represent the electrons for oxygen, and the green ones represent the electrons for carbon. We see that carbon has a total of 4 in its outer level. We have 2 inside, but on the outside we have 1, 2, 3, 4. So all those are for carbon. Over here for oxygen, you have 2 right here, and then you have 4 more going around for a total of 6 valence electrons. Same for this atom. So what happens is, oxygen will allow the carbon atom to use these 2 for its valence level, and carbon allows this atom to use these 2 from its valence level. The end result is that both of these have 8, because over here also you have 6 in the valence level of this oxygen atom, which are being shared with the carbon as well, and carbon is sharing 2 with this oxygen atom. So all 3 atoms have a total of 8. They all have an octet. Now, you don't have to be able to draw these kinds of images. This is just an example to show you what a covalent bond looks like and what it represents. What you do need to be aware of is how to name them. And the reason that we have to be able to name them is because when we have different configurations of nonmetals coming together, we can have the same elements forming different compounds. So we can have, for example, we can have carbon dioxide, which you can see right here, and we can also have carbon monoxide. And so for that reason, we have to be able to designate between the two. Additionally speaking, we can also have water and hydrogen peroxide. Again, the same elements, but a different pattern or different configuration for how they're combined. So when we look over here, we see the prefixes. The prefixes reveal the number. So we would actually call this carbon dioxide. You don't say mono if it starts with mono. So you would not say monocarbon dioxide. You don't say that. You don't have to say monocarbon monoxide. You just say carbon monoxide, carbon dioxide. The same over here. Dihydrogen monoxide, and this is actually called hydrogen peroxide, but if you want to name it a different way, you could say dihydrogen dioxide. Okay? So, looking at these examples, how would I name these? Again, using the prefixes. The name for the first one, as we've already said, is carbon dioxide. Over here, I have NH3. We would call that nitrogen trihydride. SO4 would be called sulfur tetraoxide. And then down here again, this would be carbon monoxide. What I would like for you to do at this time is I would like for you to take these examples that I have, and I would like for you to stop the video and try to solve these. Again, just write the name down for the compound. All right, so now that you're finished, let's just check your work and see if you were correct. The first example, HCl, this is hydrochloric acid. We would call it, naming it by the compounds, by the prefixes, we would call it hydrogen chloride. Again, there's no prefix, we would call that hydrogen monochloride. Because the mono would represent one, we have one atom of chlorine. The second one we will call dinitrogen tetraoxide. The third one is going to be phosphorus trichloride, H2O, dihydrogen monoxide, and the last one, it's a pretty large molecule, that would be called dinitrogen pentoxide. All right, so I think you have the basics down for how we name covalent bonds. Thank you.